This is Geometry Lesson 9-5 Dilations. The objective of this lesson is that you will be able to understand dilation images of figures. Alright, so let's just kind of talk about what this word dilation means. Basically what this lesson is going to be about is the idea that we can use a scale factor to make something larger or smaller that's going to be similar to what we began with, okay? So when we have a dilation, where it is written right here, then we're always going to have a center and we're always going to have a scale factor. Okay, so the center tells you where those kind of distance are being increased or decreased from, and then the scale factor tells you how much bigger or how much smaller you're going to make your shape. So if you're looking at this kind of picture up here, we've got PQR, our original pre-image, and you can see that then we have this image over here that is larger. Okay, so this image over here in blue, this is a dilation of PQR. If you look down kind of below, there's these measurements right here. You can see that CR right here times the scale factor equals this distance from our center of dilation to the image of R, which is R prime. And that's what it says right there. Okay, so basically all we do is we take, when we're given an image, when we're given a pre-image like this CR, we take it, we multiply it by the scale factor to get the image length. Okay, and these are similar. Okay, a dilation image is similar to the pre-image. However, it's not an isometry because the sizes are changing. And remember, isometries mean that the sizes are the same. Okay, so we're just kind of recognize and kind of look at some of these dilations here. So here you can see kind of we have some dilations here. We have an enlargement and a reduction. So an enlargement is when the scale factor is greater than 1. And a reduction is when the scale factor is between 0 and 1. So the scale factor is always going to be positive, but it'll either be between 0 and 1 or it'll be greater than 1. So this first one right here is an enlargement. We know it's an enlargement because the scale factor is 2, meaning we're making the shape larger. You can see you have your pre-image A, B, C, D, and then you have your image A prime, B prime, C prime, D prime. And if you look at these measurements right here that are given, in the pre-image, CD is 2. So we're going to take 2, we're going to multiply it by the scale factor of 2 to get 4. That means in the image, C prime, D prime should be 4, and it is. If you look at this next picture here, we have our reduction going on here because we have a scale factor of 1/4. We have our pre-image, EFGH. It's got a distance of EH that is 8. So I take 8 times my scale factor of 1/4. 8 times 1/4 is 8/4, which equals 2. So if I go check in E prime, F prime, G prime, H prime, I'm also given the length of EH right here is 2, and that's exactly what it was supposed to be. Alright, so that's kind of our idea of a dilation. We're going to do a little bit of practice with that now. So it says finding a scale factor. X prime, T prime, R prime is a dilation image of XTR. The center of the dilation is X. Is it a dilation, an enlargement, or a reduction? So we're first going to look, we've got for our pre-image, the one without the primes, that's XTR, see how that one's smaller. And then we see our image, X prime, T prime, R prime, well that one's bigger. That's going to tell us that this one is an enlargement. Now if they want the scale factor, we should know that that scale factor is now going to be greater than 1. But to find it, scale factor, we write a ratio. To find our scale factor, it's going to be a ratio of the image length to the pre-image length. And you might want to write that down. That's how you find your scale factor. So if I look in my picture, I've got my XT measurement right here. That's 4. That's from my pre-image, so I'm going to take something divided by 4. Now I'll tell you, a lot of people jump the gun and they say, ooh, there's an 8. So they go 8 divided by 4, because there's an 8 right here. Now careful. That 8 is the distance between T and T prime. whereas 4 was the distance between x and t. I want the corresponding distance to xt. That's going to be x prime t prime. So I need to figure out how long x prime t prime is. That's going to be this entire distance here. So 4 plus the 8, which is 12. So I simplify that fraction. 12 divided by 4, that becomes 3 over 1, which is 3. That means my scale factor for this one is 3. So you can see this one, it was an enlargement. You can tell that it's an enlargement because of that scale factor and because of the picture that goes along with it. Let's try another one. This one's going to be in the coordinate plane. So it says J prime, K prime, L prime, M prime is a dilation image of JKLM. The center of the dilation is 0, the origin, or O. Is the dilation an enlargement or a reduction? What is the scale factor? So we're going to look once again. We're going to look for our pre-image, JKLM right here, pre-image. You can see your image is smaller, that's located inside. Since it's smaller, that means this one's going to be a reduction, which tells us our scale factor should be between 0 and 1 this time. Now, if I look at this one, it might be a little bit hard to actually measure some distances. Sometimes you can count some sides in the coordinate plane, or you can just count a distance from the origin. So I'm going to show you 2 ways to approach this problem. The first way to approach this problem is that you might notice the KL distance right here. You can count that out. It's 1, 2, 3, 4. And then you might notice K prime, L prime right there is 2. Remember, your scale factor is your image over your pre-image. So my image length was 4. Oops, I messed that one up. My image length is 2. My pre-image length is 4. I simplify that, I get 1/2 for my scale factor. So that's one way to approach this. Now sometimes you're not given a side that's on a vertical or horizontal line, so you can't count it out. So what you would do then is you would pick a point and then you would count the distance of it from the origin. So if I notice right here, marker doesn't like to work. If I notice right here, I can count the distance from K to the origin like that, from K and then from K prime as well, so I can count both those out. From K to the origin, it's 1, 2, 3, 4, 5, 6. That's a pre-image length, so I can put that on the bottom. K prime to the origin, it's 1, 2, 3. I get 3, 6. I simplify that, I get 1/2 as well. So those are 2 different ways you can approach getting that scale factor.